Welcome to The Explainer. Today, we're talking about something you write all the time in JavaScript, functions. And we're going to show you how to use TypeScript to transform them from something that might work into something that's totally bulletproof.
Okay, so let's dive right in with a classic JavaScript problem. On the left, this greet function is basically a ticking time bomb. I mean, you can throw anything at it, a number, an object, whatever, and you won't know there's a problem until you get some weird bug at runtime. But check this out. Over on the TypeScript side, we add just one little thing, string. And that's it. We've made a rule. And now TypeScript acts like our copilot, flagging this error immediately. And that right there, that's the magic of TypeScript. It's catching these sneaky bugs while you're still typing.
So what's the culprit here? What's causing all this chaos? Well, it all comes down to this thing called the any type. When you don't specify a type for a parameter, TypeScript basically just throws its hands up and says, all right, fine, anything goes. It's kind of like turning off the very safety net we came to TypeScript for in the first place. So really, our mission is to hunt down the any type and get rid of it wherever we can.
And you know what? The fix is so simple. It's beautiful. With just a colon and a type, boom! You've turned a chaotic anything goes function into a predictable, reliable part of your application. Seriously, this little bit of syntax is probably the most important tool you have for writing code you can actually trust. Okay, so we've got the basic idea down, right? Now let's open up the toolbox. Turns out TypeScript gives us 4 main ways to define our function inputs. And trust me, you're going to be using these every single day. All right, first up, the one you'll see the most. Required parameters. This is the default. When you type a parameter like this, you're making a contract. You're basically telling TypeScript, hey, listen up. This value has to be here every single time. It's your guarantee that your function will have what it needs to work.
Okay, but what about stuff that's, optional, like a nickname or a middle name? That's where optional parameters come in. And it's so easy. You just pop a little question mark on the end, and you're telling TypeScript, this argument would be nice to have, but hey, no big deal if it's not there. So you get all this flexibility, but you don't lose any of that sweet, sweet type safety. Next up, let's talk about default parameters. These are awesome for when you need a fallback plan. So if a user doesn't give us a name, we don't want things to break, right? We'll just call them guest. You just set the value right there in the function definition, and that guarantees your variable will never be empty, whether the value comes from the user or from your sensible default. And last but not least, what do you do when you have no idea how many arguments you're going to get? Think about adding tags to a blog post. That's what REST parameters are for. You use those 3 little dots, and TypeScript just scoops up all the leftover arguments and puts them into a nice, clean array for you. It's an incredibly powerful way to handle lists of things. All right, so let's put it all together. Here's your whole parameter toolkit on one screen. See? You've got a specific tool for literally every job. Required for the must-haves, optional for the maybes, default for your safety net, and REST for when you need to catch them all. Getting these 4 down gives you precise control over exactly what goes into your functions. Okay, so we've totally locked down the inputs. That is a huge win. But a function is a two-way street. So now we've got to talk about the other side. What comes out of the function? Because really, if the output is unpredictable, we've only solved half the problem. And that's the million-dollar question, right? If you can't trust what a function gives back, you're just pushing the potential for bugs further down your code. The next thing that uses that output is still at risk. Now, don't get me wrong, TypeScript is pretty smart. A lot of the time, it can just look at your code and figure out what you're returning. That's called inference. But just letting it guess can be a little risky sometimes. When you explicitly add that return type yourself, you're not just doing TypeScript a favor. You're leaving a clear signpost for anyone who reads your code later, and that includes your future self. And that's really the heart of it. When you explicitly define a return type, you're making a promise, a contract. You're guaranteeing to the rest of your app, no matter what happens, this function will give you back a value that looks exactly like this. That promise is what makes your whole system more reliable. Okay, you ready to take it up a notch? For our last concept, we're going to get a bit more advanced. So far, we've been talking about what's inside the function, right? The parameters, the return value. But what if you need to define the type of the function as a whole? This is super powerful, especially for things like callbacks or event handlers. Okay, I know this syntax looks a little weird at first glance, but it's actually super logical. Think of it like a recipe. First, you list your inputs, the parameters. Then that little arrow says, and this will give you,
And then you state what comes out, the return type. It's like creating a reusable blueprint for a function. So why would you do this? What's the big deal? Well, it lets you say, this variable can only hold a function that looks exactly like my blueprint. Imagine you have a button that needs an on-click function. By typing that prop, you guarantee that whatever function someone tries to give it has to match the right pattern. No more guessing games. All right, let's wrap this all up. What we've really done here is gone on a journey from chaos to control. TypeScript lets us lay down the law for our functions, what goes in and what comes out. We've got a parameter toolkit, we've got explicit return types to make a clear promise, and we've got function shapes for creating these reusable patterns. And it all comes back to one thing, making our code predictable. Because predictable code is safe code.
And that's pretty much the whole story. So I want to leave you with a question to take back to your own code. Think about the functions you write all the time. By applying these simple patterns, how many future bugs could you stop before they even happen? How much more robust and bulletproof could your codebase become?